When we apply Newton's second law, generally in dynamics, the first thing we want to do is to represent the situation and to place all the forces that we know happen. So that box is, of course, having a gravitational force towards the bottom and a normal force that is in this case equal to the gravitational force towards the top. And the reason for that is because there's no other vertical force and there's absolutely no movement happening vertically or going down or going up. Then we want to put the applied force by the man, so he pushes on the left towards the right. So that force starts on the extreme left of the box and goes towards the right. Then we want to represent the friction. The friction always is against the solids on the floor, towards the left, against the movement. So here we represented our four forces, and now we want to project them in order to calculate the final acceleration using Newton's second law. So once we represented all those forces, make it a little smaller. The next step would be to write all the forces. So if I want to sum up all the forces, I have insert equation. So the sum of all the forces, oops, what's happening? So the sum of all the forces equals gravitational force plus the normal force plus the applied force plus the friction force. And if we apply Newton's second law, we know that the sum of all the forces is equal to the mass of the object times its acceleration. So with this vectorial equation, we'll be able to calculate the acceleration of the box. So I'm going to start by projecting all those vectors with giving them a name on each axis. So I'm going to insert an equation, make all those vectors into a matrix. For that I need two lines because I'm in 2 dimension. The upper line would be fgx plus nx plus here fx plus fsx. And the bottom line would be exactly the same, but with y's instead of x's. So I'm just going to replace the x's with y's. Oops. So once we projected all our forces, this is equal to m can be taken out of the matrix, and in the matrix it's going to be ax and ay. Up, ax, ay, and ax. Okay, so now that I have the projection of all my vectors, what I want to do is identify the values of all the vectors that I can identify. I just know that the x value of the gravitational force, because it's vertical, is 0. Same for the normal force. Its value is it's vertical, so its value horizontally is 0. The applied force, they gave it to us here, it's 103 newtons. Can replace it now. And the solid friction, all I know is towards the left, so it's negative, and it equals the kinetic friction coefficient times the normal force, and that's time normal force, and this equals m times a. I know that the acceleration is horizontal, so I can insert here a 0 value for the vertical acceleration, because I know that the box is not lifted or going down in the ground. So now vertically I can identify that the gravitational force is negative because it's going toward the bottom, and it's mass times gravitation. I know that the entirety of the normal force is toward the top, it's vertical, so, and it's positive, so I can replace ny, which is the projection, with n, which is directly the normal force, the entire value of the normal force. And I know that both those forces are horizontal, so their value vertically is 0. So now I have two equations. If I want to rewrite that with removing all the zeros, I have now two equations. I have the bottom equation that tells me that minus mg plus n equals m times 0. So I'm gonna write that down. So minus m times g plus n equals m times 0. So same thing than saying than 0. And the result of this is I can deduce that n equals n equals m times g. Now that I know the value of m, I can take the first line and replace n with mg. So the second line tells me that 103, I could have actually kept f, but generally you want to replace the letters by numbers as late as possible in physics, but it's okay for this time. So I'm going to write that 103 minus mu k times, and now I'm replacing mg by n by its value, which is mg, and this equals m times the acceleration. So now I will isolate the acceleration because it was the initial question, what's the value of the acceleration? So acceleration equals fraction 103 minus mu k mg divided by the mass. Now I have a final equation I can replace with the values. It's 103 minus mu was 0.4 times mass was 20, and gravitational acceleration 9.81, and here the mass is 20. I just have to calculate this, so I'm just quickly gonna open the calculator, split my screens. (103) minus 0.4 times 20 times 9.81 divided by 20. So the answer is 1.226, but I see that I have only 3 significant digits on the force, 1 significant digit on the coefficient, but I'm going to consider it's a perfect value, so I'm going to ignore that for this exercise. And the mass has 2 significant digits, so I'm going to give a result with 2 significant digits. And the result was 1.226, which I'm going to bring back to 2 significant figures, and the closest value is 1.2. The unit of an acceleration is meter per squared second. And because it's a vector, I want to give the final answer as a vector. I know that the direction of the acceleration is horizontal towards the right, so I'm going to write acceleration equals 1.2 meters per second, and the direction is right. You can also put as a direction east if you want to, and we're gonna highlight that answer. So the second, that was only the first question. The second question would be, what's its speed after a few seconds? So after 4 seconds, what's its speed, knowing that its initial speed is 0 and its acceleration is 1.2 meters per second squared? This is actually not a dynamic question, this is a kinematic question, but it's always good to mix the unit together and to be able to answer different questions together. So let's go. All we know is initial speed is initial speed the initial speed is 0. It's 0 meters per second. We're gonna write it as a vector. We also know that the acceleration is 1.2 meters per second squared to the right. What else do we know? We know that the duration of the calculation is 4.0 seconds. And now we just want to combine all these, and we have one equation that tells us that the distance that you travel, vectorial distance traveled, equals the initial speed times the duration times duration plus half of the acceleration times the speed square times the time square. Up. There we go. So now we just have to replace the values. We know that everything is horizontal, so we're just going to replace it horizontally. And we know that this little piece here is 0 because the initial speed is 0. So we're going to rewrite this equation by removing everything that's not necessary, and we're going to remove the vectors. So the distance traveled equals 1/2. Acceleration is 1.2. Positive to the right. And the time is 4.0 squared. Let's put that in the calculator. There we go. 0.5 times 1.2 times 16, with a final answer of 9.6. It means that after 4 seconds of pushing the box reaches a distance travel of 9.6 meters. Of course, we can give this answer as a vector. And as a vector, it would give distance traveled vectorially equals 9.6 meters towards the right. You can also answer east if you want to. That's it for this exercise. Thank you for following us and for following it, and see you in a future exercise.